Hi, wherever you're joining me, I hope you're doing well. Welcome to India Tech Report, a podcast dedicated to chronicling and supporting the growth of India's deep tech and climate tech ecosystems, bringing you news, views, and conversations with founders, investors, industry leaders, and other stakeholders. I'm Hariarakli, and in today's episode, Neil Shah, co-founder and vice president at Counterpoint Technology Market Research, gives us a quick take on Intel's new Panther Lake processor and its potential use cases in robotics and physical AI. The Panther Lake SoC marks a defining turn in Intel's roadmap towards robotics-ready edge computing. In this quick take episode, Neil explains how the chip's modular chiplet design, delivering up to 180 trillion operations per second, could make Intel a contender below Nvidia's high-end robotics tier. He also weighs in on the physical AI applications for robots that sense, analyze, and act locally. And is there an opportunity here for India's fabless chip design startups? Stay on for Neil's views on this.
Yeah, so if you look at why there is excitement about Panther Lake is the first time when we are seeing Intel producing a CPU which is on the most advanced nodes, almost on par with TSMC, which is TSMC's N2 or 2 nanometer, or is Intel's 18A. Uh, until now, Intel has always been behind couple of nodes or generations because of its missteps in 10 nanometer, right? During the 10 nanometer, and AMD, Qualcomm, Apple all raced ahead for the last 3 to 4 years, right? And that is why we are seeing Intel struggling right now. So the all excitement is about Intel with its own Intel Foundry services is almost promising on par uh, process nodes, the most advanced process node for CPU. And what the approach it has taken is more of a chiplet architecture where it can scale the GPUs and NPUs according to the applications, right? So if the application is AI PC or an agentic AI PC, then obviously it has a powerful CPU, which is on 18A, with a new technology called designed with a new technology called backside power uh, with ribbon FinFET technology, right? So it gives them more efficiency and at higher performance at lower power, which normally x86 architecture is not known for. But the ARM architecture has been ahead on that because ARM came from low power architecture, smartphones, IoT, up to PCs now with Qualcomm and Apple, right? So that is all excitement about. And the second thing is, as I talked about the chiplet architecture, where it is also having a GPU, which is on a different node and created at TSMC actually at 3 nanometer, right? And then they have IO and other connectivity and everything, which is another process nodes, which is not even advanced. So what they have done is they have put together all these different tiles, which they call it CPU, GPU, NPU, and other IOs together into one package, which is called Serverhouse 2.5T package technology, where Intel is doing pretty well with packaging in their foundry services, and is ready with a more scalable solution, which can go and be used in multiple applications as you want. You can customize it with more GPU tiles or more CPU cores, right? And so forth, or more NPU. So right now, Panther Lake is promising almost 180 trillion operations per second worth compute power, right? With 50 tops coming from NPU, 10 tops coming from CPU, and 120 tops coming from GPU, right? So that is all it's about right now. And I still don't see a full application for Intel into physical AI at this point, but more so on agentic AI or AI PCs to start with.
Hmm. And is this the first major release of a chip like this since Lip Bhutan became CEO?
Think so because there has been Lunar Lake and Arrow Lake, but Lunar Lake was like completely fabbed at TSMC, and Uh, they chose TSMC to get lower power architecture and test it out how it does. And Lunar Lake is right now the mainstream for them, but Panther Lake is now in house in respect to at least CPU and the overall packaging. And since he has become CEO, I think this is one of the major launch, I would say.
Coming to the robotics side of all the excitement over Panther Lake, I saw in their press release as well, they have mentioned that beyond the more or less conventional edge AI devices or edge devices, they're definitely looking at offering this to the robotics market and partners, and they've also announced some partnerships already. But I'd like to hear from you as how this is significant in the case of Panther Lake.
So if you look at physical AI, right, basically what physical AI is, the intelligence which brings to a particular edge device, which could be a robot, which can be a mobile robot, or it can be a stationary robot, right? And this particular device or edge device will be filled with sensors and all the actual data, and it can learn and analyze the physical surroundings, right? And bridge it with the digital world, right? So basically, if you want to run a device, edge device, which is a robot with a physical AI, you need obviously a lot of powerful tops. I would say this Panther Lake initially with this 180 tops configuration will be for a low end robot, but ideally, if you talk about humanoids and so forth, it it will go up to like 600 tops or 1,000 tops. It's almost similar to a car, autonomous car, L3 or L4 autonomous car machine, right? Which is also a robot technically, right? So there will be two types of robots. One which will be heavy sensors, a lot of edge processing, which will be more Nvidia scale physical AI. And then you'll have light robots, humanoids, which will be good enough with these kind of like Panther Lake solutions and uh, go along with the edge market. But the key thing is how the ecosystem develops for physical AI. Because if a robot has to bridge the digital and physical world, the edge processing, the sensor processing, if it is done in cloud or if it is done on the device, it requires something what is called as LBM, not LLM, but LBM, which is large behavior models, right? Which actually makes sense of the real world. What are the ambient surrounding? What is the context? It has to move this much, right? And so forth. So that can be a cloud based, or it can be hybrid, or it can be just edge based, right? Uh, but there will be latency if it is not powerful enough to do all those kind of movements, right, on the edge itself. So that is where I think there's a big difference between the physical AI, between Panther Lake and what Panther Lake would be uh, enabling, and then what Nvidia would be enabling.
Hmm. But judging from the news reports around the release in the context of robotics, it's very clear that they are seeding the idea, in terms of their marketing, that people should start to see this as a rival to Nvidia for robotics applications, and also that I think their product managers and VPs and so on also have given commentary about how they make it very easy for the customers to integrate Panther Lake with other providers of sensors, whether it's Texas Instruments or others. And as you know, recently they have released or they I think previewed on GitHub this robotics AI software. So if you look at all of this, sort of what do you think is now Intel's robotics strategy shaping up like?
I think as I said, the amount of light robots with 150 to 300, 400 tops, that market is going to be anyways bigger one, right? When you talk about humanoids or some AGVs in the warehouses, right? So those kind of is a broader market, mainstream market, and I believe Intel, if it can strike right partnership like it has demonstrated initially, right? It can try to get into robotics market ahead of even Nvidia, because Nvidia still has very powerful solutions which might not scale down to lower. price points on the lower end of robotics market, right? So it will go to autonomous cars, it will go to high-end humanoids, right? And so forth. So I think this is a big market, and if Intel is trying to get along with this, it is great. However, as I said, it's still early days in terms of even the light robots. Even if the solutions are there, there are use cases which needs to be, and that are the behavioral models are the most important. So, how Intel is doing on that front with respect to the ecosystem to enable and optimize those different models on Intel's chipsets, right? So, I think for the first generation, as I said, I'm not super bullish about it, but as we go to second generation, third generation, maybe by 2027, we will see the market developing from the ecosystem point. I'm saying from the compute point, maybe Intel is ready, but from the software stack point and the models, which will be optimized for Intel, has to be ready, because that is the advantage of Nvidia on the higher end of robots and cars. They have this CUDA stack of libraries which can optimize easily, and they have this GROOT model N1, which has a two brain approach, which can work on the movements, actuators, and so forth, but also on the second part in taking decision as well from robot point of view independently, right? So that part, entire ecosystem part, what Nvidia has replicated in the high end of robotics, physical AR, that has to be replicated by Intel right now. Because if you look at AMD is not focusing on that so much at this point. Qualcomm is focusing on robotics, but those are even like sub 50 tops robots, right? Which are for IoT, not even for humanoids and so forth. So there's a big gap which Intel is going after, which is really good. But the ecosystem has to be developed, and the use cases and uh, the actual user experience of those robots has to be optimum to for people to buy.
Is there any opportunity for Indian semiconductor startups here in contributing to developing this overall robotics ecosystem around Intel's technologies and so on?
Hard to say, because if you look at what India can contribute is more from localization point of view. So if a particular humanoid has to work in an Indian household or in a factory or in a retail, right? So the entire behavior of that robot has to be localized, right? And needs to be trained on and optimized for the Intel chipset. So Intel has to work with the local ecosystem players, software players, and building those behavioral models and optimizing it for India. So from India's point of view, from chipset point of view, I don't think obviously there is not much we can do at this point. But on the software stack and working with Intel to build those experiences, right? Maybe if someone like a car manufacturer, I'm talking in terms of the ethos, a more integrated, can come up with humanoid, localized Indian humanoid robot based on Intel platform, right? Designed for India, made in India. I think that is where Intel can work with Indian community to deploy Intel-based robots and design and develop in India.
That's it for today. You can find links to Neil's bio and Intel's news in the show notes, wherever you get your podcasts. And if you'd like to support my work, please subscribe to my posts at indiatechreport.in. I'm Hari Arkli. Thank you for listening.